So we're on our last process of rational expressions, and these are complex fractions. Hopefully you remember what complex fractions are, and they are defined as fractions within fractions. So it's a really big fraction with little fractions involved. Now, when we simplified these back in the first week's videos, I showed you two different methods to go about it, and I'm going to emphasize both of those methods again. So, my first method was basically just do what you see. Make it as one fraction in the numerator and one fraction in the denominator. Then you can do your division process. And the way that you divide fractions is by flipping and multiplying. The second method that we talked about was the method that I called my magic trick. Now, in this method, you find the overall least common denominator between every single fraction that you have. You multiply every single fraction by this least common denominator, and what happens is it makes those individual fractions or those individual denominators disappear. And that's why I call it magic, is because it makes things disappear. At that point, you should be down to a very simple problem where all you have to do is just simplify and reduce if possible. So I have an example here which we're going to work through both methods. The first one here with method 1, just making it one fraction over one fraction, flipping and multiplying. And then I'm going to work this exact same example again by using my magic trick. So, in method 1, the key point to this problem that we need to remember is that there are hidden parentheses around the numerator and hidden parentheses around the denominator. We cannot flip and multiply yet until we've reached our goal of one fraction over one fraction. So, in the numerator, if I look at those denominators of 4 and x, I note that my least common denominator is going to be 4x, where I just multiply by missing pieces. So I'm going to multiply my first fraction by x over x, and I'm going to multiply my second fraction by 4 over 4. That gives me x squared over 4x minus 16 over 4x. And now, since each of those fractions have a common denominator, I can put that fraction together as x squared minus 16 over my common denominator of 4x. Now, I have to do the exact same thing on the bottom, so I suggest that you pause the video and see if you can finish this problem entirely on your own. Okay. So I notice my individual denominators are 4 and x again, so my LCD will be the same. This guy I need to multiply by an x over x, and this guy I need to multiply by a 4 over 4. So this gives me x over 4x plus 4 over 4x. And if I combine these two fractions together, that gives me x plus 4 over 4x. Sometimes I see people write this as x plus 4 as just 4x and it cancels out. That's not true. Notice this is an addition problem, so you must write it as an addition problem and not a multiplication problem. At this point, we've reached our goal. I have one fraction in the numerator and one fraction in the denominator. So I just have to divide these fractions. So the way I divide fractions is I flip and multiply. I take my top or my first fraction as is, x squared minus 16 over 4x, and I multiply by the reciprocal of the second or the bottom fraction, 4x over x plus 4. Now I may need to review the rules of how to divide fractions. So let me pull up those steps. So here are the steps of dividing fractions. We just finished the first step of taking the reciprocal of the second or the bottom fraction. I need to factor all of my pieces individually in hopes that something will cancel. And last but not least, I multiply it straight across. So let's move back to my example. here. So I've changed it into a multiplication problem. Now what I need to do is I need to factor these guys individually. And this one's pretty easy because the only one that actually factors is my top left. X squared minus 16 is a difference of squares, so I can factor it as x plus 4 and x minus 4. Everything else I'm just going to copy over to my next step. Now I just basically cancel identical factors. So let's see what I have here. 4x cancels with 4x, and x plus 4 cancels with x plus 4, and so all I have left is x minus 4 in the numerator, and everything cancels in the denominator, which leaves me with just a 1 in the denominator. But this is not the most simplest version of this, so I would not expect you to hand this in. I would expect you to give me the most simplest version of this, which is just x minus 4. So we have simplified this complex fraction by using method 1, where I just get one fraction in the numerator and one fraction in the denominator, and then flip and multiply. Now let's look at this exact same example, which should give us the exact same answer that we did the first time, but we're going to do it using method 2, my magic trick method. Because in this method, after my first step, all of those little fractions or all of those little denominators should disappear. So the first thing that I need to do is to figure out what my LCD is. And this is actually really easy, especially since we just did it in example 1. If I look at all of my denominators overall, I notice I have a 4 and an x. So my overall LCD is 4x. What we do then is I multiply all of these individual fractions by this 4x. So I'm going to write this out. It's going to become very messy, but after that it should become very simplified because everything should disappear. Your magic. So I have x over 4 times my LCD of 4x. And notice you're multiplying this in the numerators only, so if you need to think about it over 1, that's perfectly fine. Minus 4 over x times my LCD of 4x, all over 1 over 4 times my LCD of 4x, plus 1 over x times my LCD of 4x. So at this point, it's very messy, but it will become a lot prettier here in a moment once I cancel all of these things out, once I make all of these individual denominators disappear. So the purpose of this is to cancel. So don't multiply anything out because it should get smaller rather than larger. So looking at my first set of multiplication here, notice I have 4 divided by 4, which cancels. And once I do that, that just leaves me with x times x over 1. Well, I'm not going to write the over 1. I'm just going to write the x times x, or x squared. Minus, and I get to do the same thing again over here. Notice that x over x cancels, and so that leaves me with 4 times 4, or 16. In the bottom, 4 over 4 cancels, which leaves me with 1 times x, or x, plus, and the last time I have to do this cancellation or disappearance act, x over x cancels, so 1 times 4 gives me 4. So the first step is definitely messier than we would hope to see, but notice this second step is very simplified. I've changed this down to one simple rational expression. Now all I have to do is simplify. The rules of simplifying are factor both the numerators and the denominators in hopes that something cancels. The top is again difference of squares of x plus 4, x minus 4, over my denominator of x plus 4. These x plus 4's cancel, leaving me with this right here. So I have my final answer of x minus 4. So again, at first, I can understand where this magic trick is pretty intimidating, but once you get used to it, it actually should be a much quicker and faster process than even the first method that I've showed you. If this is confusing with variables in it, I suggest that you go back to week 1's videos, see how you do it with just numbers or just basic fractions. So again, reviewing the steps of 2 different methods of complex fractions, and that's where I get to finish up this video, and actually that's where I get to finish up rational expressions overall.